Dear students, in the previous classes we have discussed how to assign utility numbers to individual preferences and also defined what is a utility function. A utility function is a way of assigning numbers to commodity bundles in such a way that bundles getting a higher preference will be assigned a higher number compared to a bundle getting a lower preference. Now, depending on particular assumptions about a consumer's preferences, utility functions and indifference curves derived from them. Indifference curve is a major tool used to describe consumer preferences, which we will discuss in detail. So, depending on assumptions about consumer preferences, that is depending on the assumptions which we make about the preferences of a consumer, the utility functions, and also the indifference curve associated with the utility functions can take on a number of shapes. Utility functions and indifference curves can take a number of shapes. We will consider specific utility functions and indifference curves associated with the utility functions later. Now, the classical shape of a utility function assumes that a commodity is desirable. The classical shape of a utility function assumes that a commodity is desirable. That is, as the amount of the commodity increases, utility from the commodity also increases. So, an example, consider x u. Suppose that ux is equal to ln x. Ux has the shape ln x. So that ln 1 is equal to 0, this point, and suppose that the utility function is like this. So the classical shape of the utility function assumes that a commodity is desirable. As the amount of the commodity increases, utility also increases. In the figure, as x increases, ux also increases, but at a diminishing rate. So this assumption is the assumption that commodity is desirable, and this assumption is stated in the form of an axiom. The axiom is the third axiom, non-saturation. The axiom is known as non-saturation. The axiom is more of a commodity is preferred to less. More of a commodity is preferred to less. That is the axiom non-saturation. More of a commodity is preferred to less. Remember this. We make an assumption about preference. Preference of a consumer. A consumer is always assumed to prefer more of the commodity to less. And if this is the assumption about preference, then the utility function associated with this type of preference and also the indifference curve derived from such a utility function assume specific shapes, and we will explain utility functions satisfying this axiom and also associated indifference curves. We will also consider the shape of indifference curves when the preferences violate this assumption. That is, we will consider the shape of the utility function and also the associated indifference curve when the non-saturation assumption is not satisfied. This is a classic example of non-saturation. If ux is equal to ln x, then as x increases, u increases, but at a diminishing rates. The axiom states that a consumer can always do a little bit better by consuming more of the commodity. Stated differently, a commodity is considered as good or desirable as against bad or undesirable. So, non-saturation assumption states that all commodities are good, desirable against bad, undesirable. And in the case of a bad commodity, more is not preferred to less. In the case of a bad commodity, less is preferred to more. Now, assuming that the utility function is desirable, is differentiable. Assuming that the utility function is differentiable, non-saturation axiom requires that the first order derivatives of the utility functions, the first order derivative of the utility function, that is marginal utility, is positive. Non-saturation axiom requires that marginal utility be positive in mathematical terms. That is, if the quantity of a commodity consumed increases, marginal utility increases. That is, if u is equal to x1, x2, etc., xk, then non-saturation axiom require that marginal utility of the jth commodity, that is dou u by dou xj, greater than 0. J is equal to 1 to k. Muj, dou u by dou xj, greater than 0, and j is equal to 1 to k. And remember this, only the sign of mu is important. The actual magnitude is not significant, as utility is considered as ordinal utility only. Since we consider utility only as ordinal utility, what is important is the sign, not the magnitude. And suppose that u is equal to xy. A utility function is given as xy. Then mu1 is equal to dou u by dou x is equal to y. Mut is equal to dou u by dou y is equal to x. And this utility function satisfies the non-saturation axiom. If the utility function is given like this, uxy, then mu1, marginal utility of x is positive, y is positive, satisfying this axiom. Now let us see what is the implication of this axiom graphically. Consider x and y, two commodities. You can take it as xy or x1, x2 as your choice. You consider a point here. Consider a point x1, y1. A bundle x1, y1. Denote it as x. denote this bundle as X. Now, if you compare this bundle with any bundle in this shaded area, non-saturation axiom states that any bundle such as Z, M, U, etc. are preferred to X. That is, given an initial bundle X, any bundle consisting more of at least one commodity is preferred to an initial bundle. On the other hand, a bundle here or bundle here is not preferred to X. So non-saturation axiom says that given an initial bundle, any bundle which consists at least more of one commodity is preferred to the original bundle, and the shaded area is preferred, whereas bundles given in these areas are not preferred because these bundles will not contain at least more of any commodity. Now, axioms 1 and 2, namely completeness and transitivity, provides necessary assumption for a consumer's preference ordering or ranking. Given the axioms of completeness and transitivity, a consumer can rank all the market baskets, all the commodity bundles. And these two axioms determines what is known as the indifference set. These two axioms determines the indifference set. The indifference set of commodity bundles, where within each set the consumer will get same level of satisfaction. Given these two axioms, we can always define the indifference set of commodity bundles, that is, bundles which give a same level of satisfaction to the consumer. And a consumer will be indifferent between any bundles in the indifference set. And axiom 3, that is, non-saturation, provides the direction of increasing utility given a change in commodity bundle. It gives idea about direction of increasing utility. If you move towards the right, and if a bundle contains at least a little more of one commodity, it provides more utility than the initial bundle. So the third axiom provides the direction of increasing utility. The first two enables us to define an indifference set where a consumer is indifferent between bundles in the indifference set. So in terms of preferences, these three axioms are all that is necessary for determining utility maximizing bundle. In terms of preferences, these three axioms are all that is necessary to determine which bundle maximizes utility. So let us summarize these axioms and its implications in the form of a table. Now, the first axiom is completeness. And its implication is, completeness means it has two implications. One, no gap in commodity space. No gap in commodity space. That means a consumer is able to rank all the bundles in terms of desirability. Also, it also means any two bundles can be compared. Two bundles can be compared, and this is rational behavior. Rational behavior. The second one is transitivity. Transitivity enables us, its implication is orders bundles in terms of preferences. And we have defined rational behavior in terms of completeness and transitivity. Transitivity enables us to order bundles from the most preferred to the least preferred. Then third one is non-saturation. Non-saturation, its implication is households can always do a little better. Do a little better by consuming more of at least one commodity, and it is necessary for utility maximization. Do a little better, non-saturation. And the fourth axiom is that we will see is diminishing marginal rate of substitution, also known as strict convexity. It's a point which we will see later. And we will discuss diminishing MRS or strict convexity. It means averages are preferred to extremes. Averages are preferred to extremes. So, given these axioms, we can determine the bundle which maximizes a consumer's utility. And remember this, depending on the assumptions concerning household preferences. In the theory of consumer behavior, consumer preferences are important. If you know the consumer preferences, you can assign utility numbers. That is, you can define the utility function. So, the form of the utility function depends on the nature of preferences. The nature of preferences. Depending on the type of preference, you can specify the underlying utility function. Or if the utility function is known to you, then you can explain the nature of preference. And also you can derive indifference curves that we will see later. And the shape of the indifference curve depends on the type of utility function we consider. And we will explain various type of utility functions and associated shape of indifference curves, etc. And remember this, one important assumption about household preferences is non-saturation. More is preferred to less. All goods are goods. This is a point which we will discuss later. So, in terms of preferences, these are the axioms required to determine the utility maximizing bundle, the bundle which maximizes a consumer's utility.